Do you experience that sometimes you're sitting in an exam and suddenly there's one task that the teacher never practiced with you before and you have no idea where to even begin to solve it? Or you're in class and the teacher picks you and you kind of remember some facts and feel like the answers are right there, but you just can't put it together? In those situations, something called first principle thinking might be the solution. So in this video, I'll explain to you exactly what it is, show you how it works with the 3 questions that solve any problem, and apply it to solve both of these situations above. So what is first principle thinking? It's breaking down ideas to the most basic building blocks and then building up your understanding from there. The great thing is, this works even when you have never seen an idea or problem before, using only the facts right in front of your eyes. So let me show you how this works in action. Imagine you're sitting in a maths exam and you can solve some tasks with the formulas you practiced, but then you come to this question that's worth 20% of the entire exam and you have no idea how to solve it. A train leaves station A at 2 p.m. traveling 60 km per hour. Another train leaves station B at 3 p.m. traveling 90 km per hour. If the train stations are 300 kilometers apart, when will they meet? So what do you do now? First, you ask yourself, what do I know for sure? So you write down the facts you know to be true because they are stated in the task itself. In this case, train A leaves at 2 p.m. going 60 km per hour. Train B leaves at 3 p.m. going 90 km per hour. The trains are 300 km apart, and because the task says that they will meet, that means they're moving towards each other. Then you can ask yourself, if those facts are true, what else must be true as well? If the trains are moving towards each other, that means the gap between them is closing. So at what speed is it closing? Train A moves at 60 km per hour and train B at 90 km per hour. So 60 plus 90 equals 150 km per hour. But train A had a head start. It left the station at 2 p.m. while train B left the station at 3 p.m. That means train A has already traveled 1 hour until train B even starts to move. Since train A's speed is 60 km per hour and it traveled for 1 hour, 60 times 1 equals 60 kilometers. So the real gap when both trains are moving is 300 kilometers minus 60 kilometers, and that equals 240 kilometers. Now that we figured out that the gap is 240 kilometers and it's closing by 150 kilometers per hour, we can ask ourselves, what follows from that? The question was, when will the trains meet? So, the trains close 150 kilometers every hour. We need them to close 240 kilometers total. So how many hours of closing 150 kilometers does it take to reach 240? That's 240 divided by 150, which equals 1.6 hours when you type it into the calculator. 1.6 hours is 1 whole hour plus 0.6 of an hour. There are 60 minutes in an hour, so 0.6 times 60 equals 36 minutes, meaning 1.6 hours equals 1 hour and 36 minutes. Going back to the question, train B started at 3 p.m. 3 p.m. plus 1 hour and 36 minutes equals 4:36 p.m. So the answer to the task is, the trains meet at 4:36 p.m. We went from having no idea where to even begin to solve this task to having a finished answer just by asking these 3 questions. What do I know for sure? What must be true if those facts are true? And what follows from that? Now let's apply this to another example to see how it works in a different context. This time you're in chemistry class. Last week you learned something about sodium and electrons, but honestly you weren't paying full attention and now you only remember half of it. The teacher looks directly at you and says, "Can you explain why sodium reacts so violently with water?" Now everyone's looking at you. You know it has something to do with atoms wanting to be stable and something about electrons, but you can't remember the exact explanation your teacher gave. But then you remember the 3 questions, and you do remember one basic thing from last week. Atoms want full outer electron layers to be stable, like noble gases. The teacher has said that like 1,000 times, so you know it probably has something to do with this too. So you ask yourself the first question: what do I know for sure? Sodium is a metal. That's something from last week that you remember clearly. Water is H2O, so that's hydrogen and oxygen. When you drop sodium in water, it explodes violently. You just saw that in the demonstration of the teacher. And of course, that one thing you remember. Atoms want full outer layers to be stable. So sodium probably doesn't have a full outer layer, and oxygen probably doesn't either. Otherwise, they'd already be stable and wouldn't react. Now to the second question. What must be true if those facts are true? If sodium reacts that violently, it must really want something from water. And if atoms want full outer layers, sodium must be trying to either give away electrons or take electrons. Metals usually give away electrons. You vaguely remember that since it came up a lot of times in the last lesson as well. So sodium probably has extra electrons it wants to get rid of. And oxygen in water must want to take those electrons. So sodium gives electrons and oxygen takes them. When atoms trade electrons like that, energy gets released. And if the trade happens fast, that's a lot of energy released all at once. So third question, what follows from that? Hence, when sodium hits water, sodium immediately gives away its extra electrons to oxygen. Both atoms get what they want: full outer layers and with that stability. All that energy from the electron trade releases violently in one moment. That's the explosion. So the answer is, sodium reacts violently with water because it wants to give away its extra electrons to become stable. Oxygen in water wants to take those electrons, and when they trade, a lot of energy releases all at once, which causes the explosion. And that's how you just put together the complete explanation from just a half memory about atoms wanting stability. And since you spoke your reasoning out loud as you were doing it, your teacher nods, impressed that you actually thought it through instead of just trying to repeat memorized facts or not responding at all. So that's how first principles works, and now you saw how it works in both of these situations. To recap, here's what you can take away from this video. When you need to solve a problem you've never seen before, ask yourself, what do I know for sure? What must be true if those facts are true? And what follows from that? The key is knowing the basic facts of each topic, like the fact that atoms want full outer shells in chemistry. From those basics, you can reason up everything else. So when you prepare for exams, those basics is what you should focus on, before spending a lot of time practicing random tasks and getting confused. And if you feel like you can't figure out what those core basics are for the exact subjects and topics you need to study for, I have already done that work for you and wrote an entire ebook filled with all the core basics and examples from subjects like chemistry, math, history, and so on. It's linked in the video description and the pinned comment below. If this video helped you, you might also enjoy my last video about what I call reverse application. You might have noticed that when you need to solve a completely new problem, first principles is the solution. But sometimes things are similar to each other, and what works for one problem works to solve the other problem as well. That way you can take what you already know and understand from subjects you're good at or even your hobbies and use it to solve difficult tasks in school. In that video, I show you how you can do that effectively as well. It will appear in the end card in a few seconds. And when you have any questions about this technique and how to apply it to your life, or any other questions about studying smarter, feel free to ask them in the comments below, and I will read them and respond to you. And when your question deserves a whole video of its own, I will make that the next video for you. So see you in the comments and see you in the next video.